This video we look at alternating current, which is AC. AC is the important format of electric power that we use in a lot of homes and a lot of industrials. Sinusoid is one of the popular format of AC. The power in the outlet of our homes takes the sinusoidal form. The voltage is actually have this format V of t equals Vm sine omega t. We know in our household the frequency of sinusoidal wave is 60 Hertz. We know sinusoid is periodic. The function repeats itself every t second. T is equals 2 pi divided by omega. For example, if V of t equals to 2 sine 4 pi t, then t equals to 2 pi divided by 4 pi. That equals to half. That's second, which means that every half second, this waveform repeats itself. So this is period t. The frequency is 1 over t. The frequency unit is hertz, which means that how many times the waveform repeats itself in 1 second. Basically, how many cycles within 1 second. This is a physical meaning of frequency. The frequency here, f equals reciprocal of period. The unit is hertz. The angular frequency, omega, equals 2 pi f. That is radians per second. If there is an initial phase shift in the waveform phi, we can write in this format Vm, that's magnitude, sine omega t plus phi. Phi is the initial phase shift. This two sinusoid, V1 equals Vm sine omega t, which means that the phase shift for V1 is 0 degree, and V2 equals Vm sine omega t plus phi. The only difference, V1 and V2, there is a phase difference, phi here. Now let's look at the waveform. So if I plot omega t, the x is omega t, and this curve is V1 of t. It starts with 0, because when t equals 0, sine 0, that's 0. When omega t equals to pi, that's 0. When omega t equals to 2 pi, that's 0. So that's a sinusoidal wave. This is a sinusoidal wave. It is a 1 cycle here. And yet half pi, this is a half pi, this is pi half, and sine half pi equals to 1. So the value of V1 is equals to Vm. And just go on because it's periodic. You just go next cycle. That's V1. Let's look at V2. V2 phi, suppose phi greater than 0. So in this case, phi is greater than 0. This is a minus phi here. When omega t equals to minus phi, V of 2t equals 0. So it starts with minus phi here. And then follow the sinusoidal waveform shape. And at 0, at t equals 0, t equals 0, V of 2t equals to sine phi. So depend on the value of phi here, look like this graph, phi equals to half pi here because it has the value of Vm here. And then it follows the shape of sinusoidal wave. Now let's introduce the concept of in phase. When two sinusoids are in phase, they reach the maximum and minimum at the same time. In this case, they are in phase. These two waveforms V1 and V2, apparently with phi not equals 0, they are not in phase because they reach the maximum at different time and they reach the minimum at different time. So these two waveforms are not in phase. As a matter of fact, in this case, V2t, that's V2t, actually leads V1t by phi because there's phi here and here V1, the phi is equals to 0. Or the other way around, V1t lags V2 by phi. Note the unit of phi is degree here. Next, let's look at trig identities. We use them a lot. First of all, sine omega t plus 100 degree or minus 100 degree, that equals to minus sine omega t. In other words, minus sine omega t equal to sine omega t plus or minus 180 degree here. So there is a degree here, the unit. Cosine omega t plus 100 degree, that equals to minus cosine omega t, or cosine omega t minus 100 degree, that equals to cosine omega t. Now sine omega t plus 90 degree, that equals to plus cosine omega t. Sine omega t minus, I use different color, if it is equals to minus degree, that equals to minus cosine. Now cosine omega t plus 90 degree, that equals to minus sine omega t. And if cosine omega t minus 90 degree, that equals to plus omega t. So totally there are 4 relationships, and each relationship has a plus and minus 2 scenarios. If we cannot memorize all of them, we can put it into a formula sheet. One of the important identity is Euler's identity. E to the power j phi equals cosine phi plus j sine phi. E to the power minus j phi equals cos phi minus j sub phi. Pay attention to plus sign and plus sign here, and minus sign here, minus sign and minus sign here. The other two important trig identity is sine A plus or minus B equal to sine A cosine B plus or minus cosine A sine B. So this is one relationship. The other one is cosine A plus or minus B equals cosine A cosine B minus and plus sine A sine B. If it is a plus sign, that's here is a minus sign. If it is minus here, here is plus. Okay, so this is another two important relations. Others, we have this relationship of pi corresponding to 100 degree. So this is a radian, this is a degree. And pi over 2, that's corresponding to 90 degree. We also have sine pi equals to 0. That equals to sine 0. I'm talking about radians now. And cosine pi equals 2 minus 1. Cosine 0 equals to 1. And sine pi divided by half, that equals to 1. And cosine pi divided by half, that equals to 0.